All right, 6.5 is introducing you to what we call polynomials. It sounds absolutely terrible, but it's really not that bad. I would say you really need to grasp the understanding of what a polynomial is and how things are able to be combined or put together. And you need to understand this really well before you move into the next class. So if you finish this class or this unit, which is the last one, if you finish this class and you do not understand polynomials, you will definitely, and you do pass the class, you will definitely need to find a tutor right after fall break to get you up to speed on polynomials. Otherwise, you are going to fall really far behind really fast. Okay, so I'm going to write an example problem up here, and you are not going to panic, okay? So the first problem is 3x to the fourth plus 6x to the third minus 2x squared plus 5x minus 7. Okay, there are things that I need you to learn about the problem that you see. First of all, this problem is listed in what we call kind of a standard form. And so let me explain to you what that means. This is listed in descending order, meaning from the biggest to the smallest. And I know that if you don't have a trained eye for this, you don't yet see that because 3 is smaller than 6 and -2, it's all very confusing. We are not talking about those front numbers. We are actually talking about the exponents. X to the fourth, x to the third, x squared, x, and then just our number, okay? That is descending order, okay? That is what we consider kind of a standard form for polynomials. They need to be in descending order from biggest exponent power to smallest, which is actually one that doesn't even have an exponent, okay? All right, so now that we've established that it is in the correct order, we're going to talk about something second, okay? So first thing we talked about, it was descending order. Okay, we just talked about descending order. The second thing we're going to talk about is a term. A term is separated by an add or subtract sign. So here's your add and subtract signs. They separate each of the terms. So I'm going to underline the first term, the second term, the third term, the fourth term, and the fifth term. There are 5 of them. They are separated by an add or subtract sign. Okay? So if I ask you how many terms are in this problem, you could count 1, 2, 3, 4, and 5. So you would write 5 terms in this problem. Okay. If I asked you about another thing, the next thing we're going to talk about is degree. If I asked you what is the degree of the first term, what I'm actually asking you about is the power. So the degree of the first term meaning the first piece on the left side, the degree or the power of the first term is 4. So that answer will be 4. The next thing I want you to see is what we call coefficient. C-O-E-F-F-I-C-I-E-N-T, coefficient. And if I say what is the lead coefficient of the first term? Well, this is what you wanted to do when I first started talking about descending order. You wanted to look at that number that was in the front. The lead coefficient, I want you to think about it like elementary school. Lead coefficient means the leader, right? The leader of this whole problem, if they say lead coefficient, it wants to know what the front number is of the entire problem. If they ask you for the coefficient of the first term, you're going to list the number that's in front of the variable, which is a letter, and give that. So I want to know, what is the coefficient of the first term? Well, that guy would be 3. What's the coefficient of the third term? Well, this is my third term. The coefficient of that is a -2. What I did here and wanted to point out is I want you to see that they're boxed together by whatever's in front of them. So the symbol that's in front of it goes with it. So this is what you have. You have 3x to the fourth, and then a positive 6x to the third, and then your third term is a -2x squared. Your fourth term is a positive 5x, and your fifth term is a negative 7. So I want you to see by boxing them in that what is grouped together. It's the symbol in front of that term goes with it. So thinking about the things that we just talked about, is this problem in descending order? X to the fourth, x to the third, x squared, x, and then just the number? Yes. How many terms are there? Terms are separated by an add or subtract sign. So we have 1, 2, 3, 4, 5 terms. The degree, talking about the power, what is the degree of the fourth term? The fourth term, I have them labeled. So here's my fourth term. What's the degree? Well, this is x to the first power. So that means that the degree of the fourth term is 1. What's the degree of the fifth term? Well, this is the fifth term. The degree is always on the variable or the letter. There is no variable, so the answer to this one is 0 because there is no letter, so there is no power, okay? So there's no answer to be given there, it's just 0. What is the lead coefficient, or what is the coefficient of the third term? We talked about that one just a second ago, right? So that's our negative 2. What's the coefficient of the fifth term? Negative 7. Fifth term is here. The coefficient is talking about a whole number, right? The whole number, or the number that's in front of the variable. There is no variable, but negative 7 is there, so negative 7 is our coefficient for that one. So if we're looking at this whole thing, this whole problem again, I want to talk about something that's a little bit different. If they ask you what is the degree of the first term, you're going to look at the first term and give me the power, right? But if they ask you about the whole polynomial, this whole problem, and they say, what is the degree of this polynomial, you're going to have to look through the problem and find the variable or the letter with the highest power. Whatever the highest power is that you see in this problem is your answer. So what is the degree of this polynomial? 4. 4 is the highest power we see here. We see 4, 3, 2, 1, nothing. 4 is the biggest one, so the degree of this polynomial is 4. Okay? All right. Let's move on to another idea. And now we're going to look at this and start talking about how we add and subtract polynomials. So let me give you a problem. That's a T. I kind of try to swoop my T's so they don't look like a plus sign. All right, so here's our problem. I have 4t to the fifth plus 10t to the third, all added to negative 8t plus 5t to the third. Okay, so if we have problems that are in parentheses, what I need to do to get parentheses gone is to distribute this to each piece that follows. And what this is this is a positive 1. So 1 times negative 8t is negative 8t. And 1 times positive 5t to the third is still positive t to 5t to the third. So what I want you to see, if it's a plus sign, it isn't going to change anything that follows it, okay? If it's a negative sign, which is a negative 1, a subtraction problem, understood to be a negative 1, it will change the signs of everything that follows, just like in the rules that we've talked about before. So since it's an addition problem, we don't have to do anything besides get rid of our parentheses and put everything all down here together. Okay, for us to put together things that match or combine like terms, I need to look at their labels when I'm adding and subtracting, okay? So these are the labels I'm talking about. The labels actually represent very different things. If you need to start thinking about these to begin with that t to the fifth are cats and t to the third are dogs and t's are goats. I don't know. Very, very different categories. So they cannot go together unless they match exactly. I'm not talking about the numbers in front of them. I'm not talking about the coefficients. You will add and subtract the coefficients once you find a category or a label that matches. So what do I have that matches? I have this and I have this. Okay, they match. Why do they match? Because they are both t to the third. So what I now have is I'm going to bring t to the third down because it's going to keep and stay part of the answer, but I have 10 plus 5. What do I get when I add 10 plus 5? I get 15. And so these two pieces have been used and they became 15t to the third. I do not have a match for either of these pieces, okay? They don't match. So what they're going to do is they're going to come down and be a part of my answer. Okay? I put a plus here because this is a positive 15. Okay? It has to have either an add or subtract to separate each of the terms. Okay? I put together two of them, so instead of having 1, 2, 3, 4, now I should only have 3 because I combined two of them. Now, this could be my final answer, but I have to double check and make sure that it's in descending order. And it's in t to the fifth, t to the third, and t. So yes, it's in descending order from biggest to smallest powers. So this is going to be my final answer. Okay, let's look at one more addition problem and then we'll move on to some subtraction. (20x to the third minus 15x to the fifth minus a negative 9x to the seventh minus 17x to the third. Okay, so in the last problem I told you to get rid of parentheses, we've got to do something with this symbol in the middle, and we've got to distribute it out. I told you that if it was an addition, right, a plus 1 in there, an addition, then you would just take what you had and bring it all down, because a positive 1 times anything is just going to give you exactly what you have when you multiply. Now we're looking at a problem that is a negative 1, which is understood a negative 1. So I'm multiplying a negative 1 times a negative 9, and I get a positive 9, and I'm multiplying a negative 1 times a negative 17, and I get a positive 17. So what I want you to see is if you multiply by a negative, it's changing the signs of everything that you have that follows it, each term, okay? So I'm going to bring this down and rewrite this, and bring down the other things that I haven't used yet. This only applies to what follows it, so it's not going to change anything in front of it. Okay, so here's my problem. This is a 17 here. All right, now I'm putting together things that match. I have what? Well, let's look through here carefully. I have x to the third, x to the fifth, x to the seventh, x to the third. I did hear something repeat, so what is it that matches? I hope you are saying the x to the thirds. Since they are the same category, you may add or subtract the front numbers. And so here's what I have. So 20 plus 17. It's an addition problem, signs are the same, add and keep the sign. So you should end up with 37, where am I at? Right, 20 and positive 17 will give you, yes, 37x to the third. All right, so the other two pieces, these are used, right? And this one, x to the fifth, x to the seventh, do not match. So I bring it down. Is this my final answer? I hope you said no because they are not in the correct order. So I need to rearrange them a little bit, okay? And so what is it that I need to rearrange? Well, I need to make sure that my biggest one goes first. So this is a positive 9x to the seventh. The next one is the fifth, so it's a negative 15x to the fifth. And then my smallest one was a positive 37, so it's plus 37x to the third. Final answer. Okay. Any questions about this one? Okay. We're going to jump back and forth between adding and subtracting to make sure that we can keep them straight. So we're going to do a few problems of each of them now. Okay, this next one is going to be 3x squared minus 8x plus 6 minus 4x squared plus 8x minus 9. Okay, before we can get rid of parentheses and start putting things together, I've got to distribute my -1 to each piece inside. Now there's 3 pieces, right? Because the terms are separated by an add or subtract sign. So that -1 will change the sign of each of those 3 pieces. So here's what I have. It was a positive 4, now it's going to be a -4. It was a positive 8, now it's a -8. It was a -9, so now it's a positive 9. So when I rewrite this, I need to write my new signs. If I don't keep it straight, my whole problem will become wrong. Remember the first terms, the first 3 here, do not change at all. Okay, no more parentheses. I distributed my subtraction sign to all of the pieces, all the terms that followed, and here's what I have. Now I'm looking for things that match. I have x squared and x squared. I have x and x. And I actually have number, just a whole number and a whole number. So the red boxes will get combined, the blue boxes will combine, and the black boxes will combine. So let's start with the red ones. I know that x squared is going to be my answer, but I'm going to talk about the numbers. I have 3 and a -4. If I change this to addition, change the sign that follows, the signs are different, so I'm going to subtract and take the sign of the bigger number. And I end up with a -1 x squared. Okay, these guys are done. Moving on to the blue. I know that they both have an x, so my answer is going to be an x. I have a -8 minus 8. Some of you got this wrong on your test and you said that this is 0. You would be wrong. Here's why. Because some of you think that you can do this in your head, and that's great, and usually you can, but you didn't think about it in the right way when you did this problem. I owe somebody $8 and then I owe somebody $8 more. I don't have $0. I owe somebody $16 now. Do you see that? Here's how you should write this if you need to see it written out. You change it to addition, change the sign of the one that follows. Signs are the same. Add and keep the sign. That's the rules for this to make sure we get the right numbers. The blues are now gone, and I'm moving on to the black ink. They are just numbers. Okay? You don't have to write the plus. It could just look like this. Signs are the same. Add and keep the sign, and so I end up with a +15. So is this in the correct order? Can I write -1 x squared minus 16x plus 15? Yes, I can. X squared, x to the first, no x. One thing I want to point out and I want to talk about is this guy right here. Right now, because it's early on, we are accepting this. But I want you to realize that there is a rule in math that will not let you submit a final answer with a negative lead coefficient on a polynomial. So you would not be able to turn in -1 x squared minus 16x plus 15. We are going to have to change the signs of all of those to be able to turn it into a +1 x squared for a final answer. But for right now, this is an okay answer until we get to that place in this chapter, okay? All right, let's do one more addition that's a lot longer, okay? And once we finish that one, we'll call it a day for this section. Gotta write nice and small because it's a long problem. Okay, this one is going to be -4 x to the 5th plus 4x to the 3rd plus 11x squared minus 1 plus. negative 11x to the fourth minus 6x to the third plus 4x squared plus 5. Okay, lots and lots of pieces here. Not everything matches, but some of them do. So I need to first get rid of my parentheses. I do that by distributing this plus sign to every single term that follows. If it's a positive, a plus sign, an addition problem, it does not change any of the signs because you pretend as if you're multiplying by a positive 1, and 1 times anything is not going to change the signs. So I'm going to rewrite and bring everything down that I can. Okay, so there's my problem. I am trying to figure out what matches. So x to the fifth has no matches, so it's going to come down. For x to the third does have a match, okay? And so this guy and this guy go together, okay? And what else matches? Well, I see the x squareds do match, so here's this one and here's this one. Okay, the whole numbers match, the -1 and the +5 match, and it looks like the x to the fourth does not have a pair, so it's going to come straight down. Okay, all right, so from here I need to work with the red boxes, blue boxes, and black boxes all separately. So x to the third is going to be a part of my answer, so I'm going to bring it down. I have 4 minus 6. That could be rewritten to be an addition problem. Give the sign, change the sign of the guy that follows. Signs are different. Subtract and take the sign of the bigger number. So I get negative 2x to the third. Okay. The blue, I'm going to bring down x squared because they're both x squared. That means the answer is going to be x squared. So I have 11 plus 4. Signs are the same. Add and keep the sign. So plus 15. The next ones are going to be our black ink, which is going to be a -1 plus 5. Signs are different. Subtract and take the sign of the bigger number, and so plus 4 is what I get for this one. So x to the fifth, x to the third, x squared, x to the fourth, and 4. None of those match, so we're going to put them in order now. And so in order would be from largest power down to smallest. So I have negative 4x to the fifth, minus 11x to the fourth, minus 2x to the third, plus 15x squared, plus 4. Yes. Final answer. Okay. All right, that's all we have for this section, which is 6.5. Make sure you contact me with any questions that you may have.